In this series of lectures, we'll be discussing about statistical model selection for some classes of probabilistic models.
A probabilistic model is a description of a procedure that can generate data with a given probability distribution.
So what we want to do is to be able to produce a sample with the same statistical features of the original sample. The goal is not to reproduce exactly the same string present in the original sample. What we need is to understand what are the really important features of the sample we got. And these are statistical features.
Statistical model selection is the task of selecting the model from a given class of models which best fits the data.
So you try to capture from the data set the main statistical features, the main aspects of the data, and you try to translate this to a formal mathematical description that is the probabilistic model in this case.
And of course, we seek for statistical selection procedures which are not only robust but also computationally efficient.
So in all branches of science, you need to assign models to real data in order to understand the main features, the main characteristics of the data, and try to understand the process generating this data.
Once the model has been selected, it can be used, for instance, to make predictions or even to classify new datasets.
This course is clearly related to data science because maybe one of the most important problems in data science nowadays is precisely model selection, where you need to adjust the dimension of your model to a given data set. When I say the dimension of a model, I'm talking about the degrees of freedom of your model.
A naive idea could imagine that data science has to do with computational power, but this is not the case. Of course, we use the computational power to be able to work with complex models, but the need of models is crucial.
In our course, the classes of probabilistic models that we'll consider include the stochastic chains with memory of a variable length, and also the space-time generalizations of this model.
We will cover also some algorithms and statistical methods to estimate the model parameters, to fit the model parameters to real data, and we will show some theoretical properties of these estimators.
As we'll see, these two classes of probabilistic models have been successfully applied to real data sets coming from linguistics, bioinformatics, and neurobiology. I hope to see you soon. Bye!